Hello again. This is Erica Puentes in QBA at Hudson Valley Community College. This video will be the second video on simple interest. I want to emphasize that these videos are just one of the many tools. Don't solely look at these videos. I'm only going to go over some of the, I'm going to go over all of the concepts, but only some of the problems in QBA simple interest throughout the whole semester. So it's very important you attend class or go online and do the homework that I have provided on Blackboard. Make sure whether it's online or face-to-face, you review Blackboard. There's a lot of important tools. I want you to remember also that you are welcome to come to office hours. Email me only through Hudson Valley email. Go down to the library in the cellar of the LAC or CASP to get additional help. So, simple interest. I am going to go over to the computer for simple interest. Okay, we're starting on, it's about slide 13. This might be review, I think, on the previous slide. This is about where we ended. And when we are discussing days from July 1st to December 8th, I give you days. I will also specify in the problem probably Banker's rule. Banker's rule means in the numerator for time, it's exact number of days. So you need to go to your day chart on the back of your formula sheet. The denominator would be ordinary interest, or you put 360 in the denominator. This is the most common in banking, the banking industry, and in this class. There are three other options that I went over. I'm not going to continue with those. So I'd like to go and give you an example. Number 11, on 10/20/04, you borrow $2,000, 5% simple interest. You repay the debt on 4/12/05. What amount do you owe on 4/12/05? Assume Banker's rule, and there's no leap year. The first thing you're going to do is write the givens. The second thing you will do is write this timeline here. This is very important, especially when I have two dates here. If you notice, immediately we go from 2004 to 2005. So therefore you have to put 12/31/04 in there, and then you find the days. Day 293, 365, and 102. So we have put money in the bank from 10/20 all the way through 4/12/05. We have to find the number of days in that highlighted area. The first thing you want to do is find the number of days in 2004. Well, since we had 365 days and we started at 293, we subtract the 365 minus 293. So we were accumulating or interest for 72 days in 2004. The second part of the timeline is 102 days. So in 2005, there were 102 days where interest was accumulated. You add those, we had a total of 174. 174 is the numerator. I said Banker's rule, so 360 is the denominator. I ask you, what do we owe on 4/12/05 or in the future? So we have the future value formula, and it's $2,046.33. You can pause now. I do ask you pause it and try exact time and exact interest. The only difference would be a denominator of 365. Find the maturity value of 1680, dated 4/20/04 with simple interest 7.5, due date of 10/30/04. Again, just practicing putting the days. and writing the timeline and writing the givens. This time we don't go between 2 years, it's the same year. So we just have to subtract 303 days from 110, and we've accumulated interest of 193. This one. We'll go to so the credit union pays 9 1/5%. Turn that to a percent or a decimal form. An account has $35.82.38 on January 1st. We make a deposit of $250 on March 4th, $375 on April 28th. How much will be on the account on June 30th? Banker's rule, very important. You write the timeline with the 4 dates on it. And the way this words, the focal point, or where we will put the value of all the money, is on June 30th. June 30th is the focal point because that's where we want to know the value of the account. So January 1st is the first day, March 4th is the 63rd, April 28th is the 118th, and June 30th is 181. We list our initial deposit and then the next two deposit. You need to find the future value of all three of these amounts on June 30th. So I'll show you the arrows to help you out here. I'd like you to pause it and write the three future value formulas for these $3 amounts. So please pause the video and record it. So here are the three future values and the calculation for the days. So for example, $35.82.38 on January 1st is valued at $37.47.17 on June 30th. The last step with all these that are valued on June 30th is to add them up. So the value of the account on June 30th is $43.85.75. That was question 13. Let's look at this. This is a credit card. And from day 1 to day 25, we owe $648. Credit cards give you a grace period. Sometimes 25, sometimes 15, sometimes 10 days. So from day 1 to 25, you owe $648.20. After that, you have to pay interest. So if we pay it 1 day late on day 26, we pay interest for all 26 days. So we owe the principal and the interest for the 26 days. I'm going to use exact time and exact interest to calculate the interest. So it's I equals PRT. And our interest was $8.54. If I do it for banker's rule, it was $8.66. Again, if I'm moving too quickly, you just pause the video. Let's talk discounts or prompt payment terms. Very often, a merchant, somebody you owe money to, perhaps a oil, if you buy oil for your home, or you purchase something from True Value that's very expensive, they'll offer you a discount, and they probably will reference it as 2/10, N/45. This means if you pay it within the first 10 days, you get a 2% discount. If you do not, then you owe the bill within 45 days. You must pay that bill in 45 days. So let's look at this This is a large invoice, $135,550, and it has the terms 2/10 net 45. So if I pay it in day 1 through 10, I get a discount of 2%, and my discount is $27.11. So if I paid it through day 1 through 10, I subtract my discount from the original principal, and I only have to pay $132,839, day 1 through 10. After day 10, I have to pay the original amount. If I pay it early, I want to know what interest I paid myself. So if you remember, I want to know the interest rate I paid myself. The formula is I over PRT. The interest that I received for paying it early was $27.11. The principal now was this amount, $132,839, and I always pay, you assume you always pay your bills on the last day of the month. So 35 days came from 45. I didn't pay it on the 45th day. I paid it on the 10th day. So 45 minus 10, I paid it 35 days early. Banker's rule, if I do this equation, I paid myself 21% interest by paying it early. Now, let's 16, right below it. I didn't pay it and got the discount, and I also didn't pay it day 10 through 45. I didn't have the money. I paid it after. So there was a surcharge or an interest rate of 1.5%, a late fee, you may call it. So if I paid it on day 60 instead of day 45, I paid it 15 days late over 360. I'm back to the original principal that I should have paid. And the interest I was charged was $135.50 times the 1.5%, or $2,033.25. So the interest rate I actually paid was 36%. Now, if I'm running a business, the business loss, not only did I not take advantage of the $27.11, but I had to pay an additional $2,033.25. If you add those together, my business loss was $47.44.25 on that for paying it 15 days late. Not only I didn't take advantage of the discount, but I had to pay a late fee. Don't forget this red is homework. Let's talk about compensating balance. Very often, maybe even on your personal checking account, they say you have to keep $200 in their checking account. So if you have $1,000 there, you really only have $800 to work with, because the bank requires you to keep $200, or there's these very large fees. So in this case, you borrow $10,000 and you borrow it at 12% interest, but part of the condition of the loan is you must keep 15% on deposit at the bank. So normally you would have a zero balance in the bank. What is the equivalent rate? Because you are not paying 12%. So let's look at this. You get $8,500 to play with, because you have to keep 10,000 times 15%. You have to keep $1,500 in the bank. So you only have $8,500 maybe to buy a car, let's say. 10,000 times 15% is $1,500. So you have $8,500 in your pocket. However, the bank says you're still paying interest on $10,000 at 12% for 1 year. The interest you're charged is $1,200. Let's find an equivalent rate. Whenever you're finding an equivalent rate, you're looking for R. So the interest you paid, we know, is $1,200, so $1,200. However, your real principal is not $10,000. Your real principal is $8,500. We're looking for rate for 1 year. Our real rate or our real interest rate we're paying annually is 14.12%, not the 12%. And I know on mortgages, they are required to give you this actual rate. On personal loans, I do not know. But you're not paying 12%, you're actually paying 14.2. Compensating balance. Okay, sometimes we know the amount we want in the future. And we're saying, okay, I want $5,000 in the future to pay for Hudson Valley next year. How much do I have to deposit today at a certain interest rate? So we are looking, here is our future value formula. We solve for instead of principal, because we're talking about putting money in the bank today, we call it a PV or a present value. And our future value, instead of S, we call it FV for future value. So here's our formula, but we're going to solve for PV, and we get PV equals FV over 1 plus RT. A very similar formula is on your formula sheet. You might want to pause, and it says P equals S divided by 1 plus RT. Okay? So if I know I have to pay my grandmother $105 in 1 year, what do I have to deposit in a bank at 5% simple interest? So here's my future value, 1 plus 5% for 1 year. And when you solve this, and you should pause it and make sure you can solve it, you need to deposit $100 in the bank today at 5% so you can pay $105 in the future. I want you to pause the video and do number 19. By the way, you should keep track of vocabulary words like debenture loan, an unsecured loan. That's a personal loan. A secure loan would be like an automobile loan, because if you don't pay, they can repossess your automobile. Or a mortgage is a secure loan. If you don't pay, they take your house. Securities, investments like bonds, stocks, notes, and we're going to talk about notes a lot in the next few slides. You have $6,000 now, or you have $6,500 in 1 year with a rate of return is 8%. Which do you choose? Okay? Well, so I have chosen, and I want you to do, I will specify on a test, I want you to find the present value of $6,500. So $6,500 at 8% in today's dollar, or today's value, is $6,018.52. So if the better choice would take $6,500 in a year rather than $6,000 now, because you can only get 8% on $6,000. Yes, you can find the future value of both of those and come to the same conclusion. But I want you to practice finding the present value. Let's do the same problem, but change the interest rate. We're going to find the present value of both, well, $6,000, the present value is $6,000 now. Or let's find the present value of $6,500, but this time I wanted you to do it with 9% interest. So it's 9% interest. When you do this equation, Your $6,500 in today's dollars is only worth $5,963.30. So it behooves you to take the $6,000 today and not wait for the $6,500, because you can invest that $6,000 at 9% and get more money. A formula I want you to write on your formula is finding the discount is a future value minus a present value. And I'm going to show you this problem. Classic problem. A debtor goes to Bank A and signs a note for $3,500, and it's due in 6 months at 9% interest. 2 months after the debt is contracted, the holder of the note, the Bank A, sells it to a third party who charges 10%. How much did the third party pay for the note? You read the entire note. You solve this as two separate problems. The first problem is the first sentence. You borrow $3,500 for 6 months at 9% interest. You find the future value. Here's the timeline. Here's $3,500, 6 months. You must find the future value of it because it's a security. It's a negotiable security. Bank A can walk around and say, I have $36.57.50 in 6 months. I'm going to have that in my pocket. Okay? So he gets that note from you. You give him a note saying you're going to pay. But he comes along here at 2 months. It's not at 6 months. It will be worth something at 6 months. But at 2 months, Bank A says, you know what? I need some cash. I want to maybe put up some more banks in the area. So I want to generate some cash. So it goes to Bank B and says, here's a note. And in 4 months, you're going to have $36.57.50. Can you give me the cash now? And the bank will say, sure. Okay, money's not worth 9% anymore. Money's worth 10%. But they're finding the present value. You have to find the present value of this $36.57. So $36.57 is a future value. You have a new interest rate of 10%, and it's only going to be held for 4 months, so it's 4 out of 12. So Bank A will get $35.39.52 in their pocket after 2 months. So I want you to stop it and think about this a little bit. You will see these over and over again in examples, in compound interest in a few weeks, and possibly on some test. This example just emphasizes the focal point. And I will specify, I wanted the focal point now. So you had to find a present value of 300 and 400 and then add it to 200. Here is a difficult one. You owe $1,000. It's going to be, you agree to 12 months as the focal point. Okay, that's where we're going to value all our money. You're going to make 2 equal payments at 4 months and 8 months for that focal point. So the $1,000, X1 and X2, you have to find a future value of all 3 of those. So the future value of $1,000, I did right here, is 1,000 times 1 plus 15% 1 year, and it's $1,150. Okay. Well, the future value of X1 and the future value of X2 equals $1,150. You can't just divide $1,150 by 2 for these 2 amounts because they're 2 different times. Okay? We have to value X at 12 months. We have to value X2 at 12 months. Well, so X1, we want to find the future value. So we have X, or X1, plus 1 plus 0.15, the interest rate. And this is for 8 months. It's going to be for 8 months. The future value of X2 is X1 plus the 15%, but X2 interest is only for 4 months. 12 minus 8. These two future values must equal 1150. So we're valuing all three of these, the 1,000, X1, X2, we're valuing it all at 12 months. So we set this future value plus this future value equals 1150. And we get each payment will be $534.88. I recommend you pause and do this problem again a little bit more slower. It's difficult. In 25, we're doing the same thing, but we want to pay it off today. On July 1st, 2005, that's the focal point. We owe $3,000, but we have the cash, so we want to pay it. So we are going, the arrow's going, the 2 hours are going to the left, so we're finding a present value. So now we have to find a present value of X1, a present value of X2, add them together to be $3,000. We don't have to do anything to the $3,000 because it's at the focal point. So $3,000 equals the present value of X1. Here's the present value of X1 and the present value of X2. Solve for the denominator, and I get 1.0583 and 1.14. Factor out the x. I factored out the x here, and I have 1 over that, and the x is over here. X1's over here. I factored out x2, and I have 1 over 1.14. I solve that to get 1 divided 1.0583 is 0.9449. 1 divided by 1.14 is 0.8772. Add those two coefficients to get 1.8221. Do a little bit of algebra, and each payment will be $1,646.47. Again, I recommend you pause. Now, we are covering section 1.9 on about page 129. And what happens is the borrower is obligated to pay a loan on maturity date. However, if the borrower makes payments before the maturity date, the borrower and the lender have to have some sort of agreement, either Merchant's Rule or United States Rule. Typically, the United States Rule is used. Okay? The Merchant Rule sets all the focal points at the final settlement date. The United States Rule sets the focal point at each of the payments. An example is the best way to show you. Okay? This is the Merchant's Rule. Okay? We owe $1,000. We make a payment against that on the 4th month, and we pay $300. We make another payment on the 10th month for $200, and we want to know how much is our final payment at 12 months. Well, the merchant rules will find a future value of the $200, find a future value of the $300, and find a future value of 1,000. And that's what I did here. So the future value of 200 is 205 at 12 months, 300 is 330 at 12 months, and 1,000 is 1150. If I subtract these two from 1150, so 1150 minus these two prepayments, the balance is due is 615 when we agreed to the merchant's rule. Okay? Everything's valued at 12 months. Let's do the exact same problem with the U.S. rule. So we have $1,000 again. We make a payment at 4 months. We make a payment at 10 months. And we want to know what the 12 months. Well, in the U.S. rule, we find the future value of $1,000 at 4 months. So this first line, from 0 to 4 months, the future value of 1,000 is 1,050. So here we are at 1,050. We make that payment of 300. So after the payment, we only owe 750 right here. That 750 generates interest from 4 to 10 months or 6 months. So the 750 generates interest for 6 months, and at 10 months, the 750 is valued $806.25. So if we wanted to pay it off at 10 months, we owe $806.25, but we only have 200. So we pay down 200, so $806.25 minus 200. After the payment of 200, we only owe $606.25, right here at 10 months after the payment. Now we have to find the future value for the last payment at 12 months. So we have 2 more months to go. We only owe $606.25, and at 12 months, our last payment is $621.41. So we owed $621.41. Merchant rule was only $615. Most of the time, it's U.S. rule, probably because it's a little more. Okay? Want to talk about mortgages. We're actually going to do a whole chapter on mortgages. But here we purchased a house for we have a mortgage of $150,000, 30-year at 4%. We know we're going to pay every single month $716. So we're going to pay for 30 years times 12 months. We are going to pay 360 times. That's how many months are in 30 years. So we are going to pay $716 for 360 months. Okay. So our principal is $150,000. Our rate is 0.04. The first month right here, that's what I ask. We have $150,000. I want to calculate the interest. So it's I equals PRT. P is 150, R is 0.04, and time is 1 month. Remember, it's in 1 divided by 12. So we paid interest of $500. Now remember, your payment is $716. Of that, $500 is going to interest. The bank gets to keep. If you subtract those two numbers, $216 will pay down your principal of $150,000. You're only paying $216 towards the $150. Ouch. So you don't owe $150,000. You subtract $216. And after you make that first payment, or at the end of the first month, you owe $149,784 after the first principal. Let's look at the second month. So the second month, you don't owe $150,000 anymore. You only owe $149,784. So we're going to calculate the interest with I equals PRT. There's your P, your R, and your T. And here's our interest, $499.28, the second month. So let's find the entire principal interest paid over 30 years. We know we're paying $716 every month for 360 months. So we pay $257,760 out of our pocket over the 30 years. We only owed $150,000. So this is our total payment minus our principal. We, over the 30 years, our total interest we paid was $107,760. This is a typical example. You were paying $107,760 because people don't have $150,000 to pay on a house. But hopefully over those 30 years, your house has increased from value from $150,000 to maybe $200,000. So you're in good shape. So this concludes the second. This concludes the second video on simple interest. I have another chapter in simple interest, so you should print out the second handout on simple interest. And the next time we will discuss a few more concepts. Thank you for your time.